Recording in 3, 2, and 1. Welcome to the IT Fundamentals Training Series. I am your host, Mark Haupt, and today we're going to talk about a tough subject for me, and that is continuing on with programming and understanding scripting, and compiled languages. So welcome. Join us. Here we roll. Welcome back to the IT Fundamentals Training Series. I'm your host, Mark Haupt. Today is episode 55. And, like I said in the intro, this is a tough chapter for me because this is not my forte, if you will. This is not my expertise. You probably have heard me talk about before, if you know me, or even in some of the intros, that there are really a couple of key areas within IT that people can forge a career. There is programming, there's networking, there's systems administration, there's basic IT work, which is where most people on the networking and the systems administration side get their start. And then there's security, which layers on top of that, that even stretches with compliance into the legal and other similar type of frameworks that are outside of IT. And then above all of that, and every single one of them has a vertical, is management in that area. And if you're in IT, you will work yourself up one of those verticals is like, for example, a network engineer tech or network engineer 1, 2, 3, then into a lead, then into an architect. And that might be, going to a senior architect. If you're a really technical person and you just love the technology, you always want to have your fingers in the technology. That's what your career path is going to look like. But if you're in the type of person that wants to do technical work and then branch over to management, you're going to break off probably at the architect level and not go to senior architect, or you may even branch off a little bit lower at the lead level and start working up the management ranks, such as the lead, the manager, the director, senior director, and then into the VP or the C level type of suite. So the reason I share that with you is because I took that path, the alternative path, which requires a completely different set of skills, competencies, and those are different things we could talk about at some point. But skills, competencies, and education is on the programming side of things. And IT Fundamentals talks about the programming here in chapter 6, and that's not where my expertise lies. But we'll work our way through that. Now, typically programmers will be the type of people, they'll go to a 4-year school, a 4-year degree, college type of scenario. Whereas the folks who do those other functions, networking, systems administration, and IT, are typically folks that would do things like the IT fundamentals type of work. But it is important for people that do the IT fundamentals type of work to also have a basic understanding of scripting and of different types of languages so that they can employ them in their work. So, for example, a network engineer will learn how to do command line programming in Cisco iOS or Juniper OS or something along those lines. And they'll learn that very specific to the networking tool that they're using. Or if you're a systems administrator, you're probably going to learn a little bit of scripting, batch files, things like that. And that's what I learned. So I have some basics like what's talked about here in IT fundamentals, but I don't have the college degree, if you will, and therefore some of these things are they're here in the book. They're a little challenging for me, and the reason I transparently share that with you is not to prep you for, oh, this chapter is going to be rough, or these types of things that we're talking about are going to not come across well in the training, but more from the perspective of, look, if you're looking at becoming one of those systems administrators, then what you find here in the IT fundamentals chapter here, let's really focus on what's necessary to understand the basics and pass the test and put that knowledge in the back of your head. And maybe not go forward with it any further. But if, on the other hand, if you're the type of person that really finds that you understand this, it comes easy to you, the math skills are there, and you think, you kind of fall in love with it a little bit, then hey, let's get this IT fundamentals thing done so you have the basics, and then let's talk about moving you into a program where you can better understand or better tinker with the scripting and the different kinds of languages and things that are available out there. So that's the purpose of that intro, if you will, is hey, there are other avenues if you want to get into this scripting and this programming, if you will, for you to learn this type of information. But let's go ahead and dive in. We're going to be starting on page 331 and going for about 4 or 5 pages in. And what we're going to do is working with assembly is what it is, where it starts at the very bottom of page 331. Now, assembly languages, what you need to know for the exam is that these are all simple ones and zeros is how all the computers work. We've already established that. So what this does in page 332 is it goes through a number of examples of how the ones and zeros, which is the binary, is translated into hexadecimal, which actually could be translated into some semblance of English as well. So if you look at the center of the page, prior to that, there's some discussion in there about the decimal to hex conversion that goes on. So the ones and zeros into a hex B02A. But then if you look in the center of the page, it's translated there into English. So MOV is we're moving a number, which is 42, into a memory register, which is called AL. Now, this is where it would really dive in. We would have to go really deep to understand how memory is segmented and registered. That's different than what you would find on a hard disk, for example. But the bottom line here is if we're looking at this command is MOV AL, 2AH. What you're seeing there is the MOV stands for move, so it's going to move the number 42, which is symbolized by 2AH, 2A, meaning that's the number 42 in hex, and H is identifying that it's hex, okay? And then AL, comma, is the register of where you're moving that to on the memory stick. Now, you'll notice there's a section there off to the right that has a semicolon and even further language that actually says move number 42 to a hex into AL. When you're doing programming, you can do what's called commenting out certain functions. All right. And so what that semicolon is doing there is it is commenting out. So when the computer reads that command, move AL, comma, 2AH, then that's the only piece that it's going to move, or it's going to actually execute in the processor and in the code. Okay. And the rest of it there beyond the semicolon is just for you and I to understand what MOVAL, comma, 2AH means. So you can write anything. You can literally write a book after that semicolon, and the computer will not execute what's after that semicolon. All right, depending on what language you're using. In this one particular, we're talking about assembly language. Depending on what language you're using, that comment out is not always a semicolon. It could be another function, another feature. So as you're writing, for example, a batch script, you need to understand what the comment out line function there is. A lot of programmers, especially when they start, or people who are like myself that are not familiar strongly with programming, they'll do a lot of commenting on there so that people that come along later on who maybe even have a stronger skill set can look at that and not have to go, what in the world is that nut trying to do in this line? And so that's the importance of that comment out feature. We have a number of scripts where I work right now that are designed to move or establish a new user in Active Directory that we wrote in essentially a batch type of scripting. And we have a whole bunch of comments in there so that as people change jobs, as people move on, the people that are new coming in will be able to read that and understand exactly what was going on. So that's an assembly language. You can think of it, it's assembling functions, every single line would be a different executable or a different function that needs to occur. So if you're looking at what's going on at the bottom in the examples at the bottom of the page, it says global underscore start, or actually it starts with section.text, global underscore start, comments out, must be declared for a link or ID. Then it says, so that start is the link ID. So then it says underscore start, do the following, move edx, comma len, that establishes the length of the message. Move ecx, comma msg, this is what you're going to write, this is what's going to pop up on the screen, and so on and so forth, bottom lines. And then you move down to where it says section data. It says here's what the message db in quotes hello world unquote, and that is the actual message that will show up on the screen. So in order to get hello world to show up on your screen, all of those things would be there within that code. All right, so we've established a couple of basics first of all, and also the assembly language. Now let's move to compiled languages. That's the next step up. These are high-level languages, and it requires a compiler, meaning it requires a function that pulls all the code together. So you see there's 3 steps here in a compiler language. Number 1 is you write the application in programming language such as Java or C++, and that's called source code, okay? So your source code, which is kind of what we just talked about in the assembly piece over here, is you'll write that thing. If you wanted to say hello world, you'll write that entire thing. That's your source code. Then the step 2 is to use a compiler to translate that source code into machine language. And so that compiler is basically a package that's a translator. So if you think about it like Google Translate, for example, or any other software that will translate one language into another, you would input, for example, a phrase into English. Let's say we say hello world in English, and then you would select the language that you wanted to output in, and it would output that to you. So that would be the compiler. And then the number 3, this step, is the executable program file, which is in Windows. It's usually the .exe file. So when you see an exe file that's starting, that you want to double click on to start, for example, to install a piece of software like I showed you a couple of weeks ago, that's all a package, if you will, where the source code is then, once the executable, it essentially calls a script and starts the assembly process, or the compiled process, and works through those steps. So these languages are typically easier to operate in than assembly. So if you look down 3/4 of the way down, here is an example of the same hello world source code, if you will, written in Java. Whereas you see at the bottom of the page 332 and the beginning of page 333, you had to write all of that to get hello world. Over here in the end of page 333, you can see where it says public class hello world bracket public static void main string blah blah blah, then those slash that's print hello world in the terminal window. So it's telling it what it wants to do. And notice that every single time there's some similarities between these. Every single time it says what you want it to output, in other words what you want it to print, the hello world part, that's encapsulated inside of quotes. So a lot of these languages, when you want to output something, or you want it to, even as we move into database type of stuff later on, as you're looking for queries, or you're querying different functions, as you're looking for things, you're going to put that in quotes. You could do that in Google right now. Go and put in Google quote your statement and quote, and what it will do is it will look for that entire string within Google instead of word by word. And so you're, in essence, when you type that into Google, you are doing a sense of programming when you do that. All right, then there's on page 230 or 334, there's a whole bunch of examples here that I'm going to let you go over as you see fit regarding compiled languages. Now, the next option is interpreted languages, and interpreted languages, again, is where it takes each line of code and it interprets every time that the program's executed. So it runs every single time, whereas compiled languages, it takes the source code and it is compiled once and executed any number of times. So what we're talking about here is if we want to type the message hello world in an interpreted language, it will read that every single time and do hello world. Whereas in a compiled type of language, it is going to run through the entire program before getting to, and you can actually tell it how many times you want it to execute. So there's a table there, 6.3, that identifies some of the differences, if you will, between interpreter versus compiled type of scenario. And you can see that at analyzing source code, the interpreter is quicker, but the compiler is slower, but actually executing the code, where in other words, if somebody's actually using it, the compiler is faster. Now, another one that's interesting here is that it is much easier in an interpreted type of scenario to do what's called debugging. Now, debugging is basically finding the problems and correcting it. And the reason for that is because it's executing line by line, and it will actually tell you on what line there's been an error, or it will stop and not proceed until you correct what error exists on that line. Whereas a compiled will run through the entire program and perhaps give you some error output. It should give you some error output, but it's harder to actually figure out where the problem is because it's running through the entire thing. It looks like the whole thing is just one big error, instead of with interpreted side. If you're marching through, it will stop, or it will show you where the error exists. So let's think about it from this perspective. If I am crossing the road and I'm in a compiled language, and I'm crossing the road, and there's a car coming at me, and if I continue to cross the road, I'm going to get hit and squashed, Frogger style, right? Okay, so in a compiled language, I'm going to move through. I'm going to keep going. That car's going to run over me. I'm squished, and my pieces on the other side will say, "Okay, it errored out. You got to go figure out where you got squished." All right. It's an extreme example. I get it. We're not going to be able to go back and because I'm squished, I'm dead. But we're not going to necessarily be able to go back and fix that. However, in the interpreted type language, what will happen is if it's like a 4-lane road and I got squished in lane 3, interpreted language will allow me to get through lane 1 and lane 2. But lane 3, it's going to say, oops, stop right here. This is where the problem existed. Let's go back. Let's fix that problem. And so, in that case, I'm going to say, oh, I'm looking both directions and I'm seeing there's a car coming that's going to squish me. So I'm going to stop and I'm going to wait. That's a little bit of a strange example, I understand, but that gives you some idea of how that works and how the importance of debugging is. All right, the next language we're going to look at on page 336 are markup languages, and everybody uses markup languages every day and probably doesn't even realize it, because this is this is where you're using web pages essentially. Now, markup languages are exactly what they sound like, and it's like taking a highlighter and marking inside of a book the things that are important. And that's kind of what the way the HTML will work, is that it will point out to you where the important parts are, the important things you need to deal with. So a markup language is actually typically something that's not executed on the computer in which it starts. So you're also looking at a situation, for example, with web pages. Probably a lot of people don't realize this. When a call is made in your web browser, say you're using Chrome or using Edge, and you want to go see the website cnn.com, you're going to reach out to it. There's going to be a network function that we'll describe later. It's called a syntax sync, and then the data is transferred. And what happens is the code is actually source code is actually transmitted down to your computer, and it's executed locally on your machine, not typically on the server on the other side. Now, within markup language, you can have scripts that are running that will execute things either locally on your machine or on the other side. So that's where you get data retrieval coming from, is that when it's executed on the server side, it retrieves that data, then it takes that data and it pushes it out, all of course in milliseconds, hopefully, out to your computer, and then that computer is presented to you. So that's the concept behind markup languages, and you can read things there. some of the interesting features with markup language is this like example they use here with tag something tag. Essentially when you tag something, or let's say you execute a script, you'll tell it, hey, I want to tag this, I want to mark it, or I want to run this script. You would do so, you put brackets around the first part that's basically saying, okay, computer, get ready, this is what we're going to do. And then the word there, it says something, the example, it's going to output whatever it says there. If it's a script, it's going to output the results of the script, or in this case, it says something, it's literally going to print something on your screen. And then when it says, then the end piece there, when it says slash tag, that's saying, okay, now we're done with that piece, we're moving on to the next. All right. So the example, the exercise 6.2 here will give you the ability to write hello world in a web page, and it's very simple. In really, if you look at step 2 there, that's the code, that's the HTML code. You could pop that up and you can operate that very easily. All right, we're going to stop right there, and then we'll pick up with scripting and scripted languages, which I'll give you a hint is 2 different things. And then we'll talk about query languages in our next episode, because those are the things that really pull back data and really enhance an HTML type of function. So thanks for joining me on episode 55 today. I look forward to sharing with you episode 56, which is almost really 55B, as we move through this segment on learning scripting, programming, and different functions of how to make these computers work for us, which is really what we're trying to get done, is that these computers will work for us. All right, well, thank you. This is the episode 55. We'll talk to you later, and go back and practice that HTML. Go back and practice some of that code. That's not something that's really easily shown, if you will, on the screen, but you can do that on your screen and kind of play around with it. Change the words hello world, change it to something else. One of the things you may want to try and do is add extra lines on there, kind of experiment. How can I do more than just hello world? How can I add something else? So give it a shot, take a look at it, and we'll talk later. Episode 55 in the books. Adios.